Hey folks, Phil Zito here, and welcome to day 16 of the BAS Bootcamp. And in today's video, we are going to start looking at programming. And that's pretty much what we're going to be looking at through most of this week. So for this week, we're going to be in the Dystek Gfx Software. And this is a graphical programming software that allows us to use graphical logic blocks in order to write programs. So today we're really going to talk about what this software is, how graphical programming works, and why it came about. So what you're looking at right here is called a GUI, or Graphical User Interface. So this is also known in some areas as an IDE, or an Integrated Development Environment. Regardless of whatever you call it, this is basically just programming software. There's two types of programming. There is line code programming, which you'll see in software like Reliable, KMC, some of the Siemens stuff, some of the Schneider stuff, among some other providers as well. And then you have graphical programming, which you'll see in Tritium, you'll see in Dystek, you'll see in Johnson Controls, and other companies as well. Now, graphical programming is definitely the most common type of programming, and for good reason. It doesn't require you to know how to code. All you really need to understand is how a sequence of operations works, and then you're able to take graphical logic blocks from your graphical logic block diagram or library. As we can see, they call it the Toolbox in the Dystek software. And we can see that if we want to do certain things like compare two analog or numeric values, or maybe go and drive a PID loop for a actual loop process that we're trying to control, we can access these things pretty easy from our library. So how graphical programming works is you start off by figuring out what you want to program. Often what I will do, and let me see if I have it open. I don't, but let me open it up if it's in recent files here. Let's see, here it is. Okay. What I will often do when I'm working with programming software is I'll go through the sequence of operations, and I will go and you'll see kind of how my programs are labeled here. Run conditions, supply fan, preheat cooling, coil valve. And what I'll do is I'll write my programs as I work through the sequence. So what would happen is you would go in my programming process, and we'll explore this more later this week, is to add physical points and physical inputs and outputs first, then add our set points, and then add our Boolean logic, which is true-false logic, and then go and add our analog logic. Now, it doesn't always work that way in life and in programming. Sometimes you iterate through those steps multiple times. Sometimes the steps are a little fragmented. But if you have that general process, you'll tend to turn out some pretty good code. And you can start to see that process in place here, right? These are some physical points and also a logical point that I'm referring to in occupied command. And you'll see that what's going on here is I'm looking for the occupied command, and I'm also looking to make sure I don't have a low temp alarm. And if those two things are true, then I turn on my fan. So that is a Boolean process. That is a true-false process. This is either true or it's false. We can go forward to the preheat coil valve, and we can see we actually have an analog process in this outdoor air parts per million PID loop. And what we can see is that I am going and driving this outdoor air damper based on this loop. Now, what happens is a value comes in here, and this is actually not parts per million. This is an economizer. I just don't have it labeled correctly. But, oh, yeah, this is mixed air temp. Man, folks, I'm sorry. It's late at night. We've been launching a program right now for anyone to get access to our courses for $10, which basically covers our licensing cost. And so my brain has been in that all day long. So if I misspeak, I apologize. But yeah, this is a mixed air loop for preheat valves, not anything to do with outdoor air dampers. It's just not typed. But that's kind of another cool thing, depending on your software, is you can actually go and change the name of blocks. So that way the blocks, when you're reading the program, you know what's going on. But this is actually an analog process. So we would have a set point and we would have a process variable. It would come into this PID loop, and then we would have an output that would go into the switch, right? And that would drive the preheat valve output. So we can see all of this starting to come together right here. And this provides us with what is called analog control, meaning that it's not just true, false, it's actually a range of potential values. So writing programming, the really big thing about writing programming, there's three things about programming. The first is you have to understand how HVAC systems are controlled. You don't have to, like if you asked me to look at a fan and tell you what kind of fan, within reason I could tell you, but I mean, I'm by no means a mechanic. I've never changed a fan belt to save my life. I've never changed a compressor. I've never done any of that stuff. Yeah, I can program. I'm probably in the top percent of programmers. And the reason I say that is because I've programmed so much. I don't say that to brag. I just say that to show you that you need to understand how systems function. You need to understand systems theory. You need to understand things like psychrometrics. You need to understand things like proper sequencing of equipment, but you don't need to be a mechanic. Once you understand the sequencing of systems, then you have to understand different things called design patterns. And we'll go through a couple design patterns tomorrow. But a design pattern, a common pattern, would be something like this economizer control right over here, where we are comparing outdoor air temp and outdoor air enable set point. We're comparing the two and then driving a Boolean output. That is a comparative pattern. And what you learn is you learn to read the sequences and then you learn to read these patterns. And so if I find in my sequence of operations something that says it shall be enabled whenever outdoor air temperature is less than 65, I know that's a comparative pattern. And so I know that's the logic I need to write. And so then the next thing logically is if we know how HVAC works and we know our patterns, then we need to know our software so that we know what blocks apply to this pattern. Fortunately for us, the majority of graphical programming software is the same. There's a couple unique things like Dystek has a for loop and Allerton has a subroutine. Johnson Controls has a state table with mux and demux blocks. So there's nuances, but for the most part, the majority of these logic blocks are the same across manufacturers. So you may, if you switch between manufacturers, you may end up having to spend an hour or two learning how to work with their software. But the good news is that most software is really pretty easy to use, and it has pretty common blocks across the board. So my big note for you here, my big thing I want you to take out of this video is one, have a clear programming process. You see how I like to chunk out my code. You see that I like to do inputs and outputs first. Then I like to do my set points. Then I do my Boolean logic. Then I do my analog logic. Understand HVAC. Understand how equipment works. Understand how sequences work, things like that. And then the third thing is understand your patterns. I told you folks, I'm tired. And once you understand your patterns, then also understand the software. If you get those things right, you will find writing programs is super easy. I'm going to put a link below this video for our program that we're running right now to help folks out with near free training. I have to say near free because I don't want to get in trouble for saying free when it's not 100% free. But check it out. I think you will find it very valuable. Thanks a ton. And if you have any questions, leave them in the comments below the video.